Welcome back, guys. So now we're going to actually learn how to create functions. And I'm going to explain functions a little more because I think it's more important to learn about functions before I teach you about data types such as integer and char. Functions are kind of required first, really. So what I'm going to do, I want you to copy what I'm doing. We're going to go void myfunc void. Okay, so let's explain this. Myfunc is a function. This function doesn't take any function arguments, so we put void in here. Now, what you can do, if you go back into main, I can call myfunc like this, and what will happen is our program, when it goes into the main function, it'll call myfunc, which will start running code in here. So if I went in here and I did printf myfunc called and put a semicolon at the end, because in C you end all lines of code with a semicolon, and everything between these brackets here is the code that gets run when you call the function. So obviously this is the name, this is the return type, and inside here goes the function arguments. Now, a void return type means we're not returning any value. That's what this means. So when you call myfunc and the return type is void, nothing is returned. So there's no need to have return. There's no need to have this. But if you did want to use the return keyword to return from myfunc earlier than you could, you would just go return like this. There's no need to pass in a value or anything like that, because it's of a void return type, which means no values returned. And if I was to have a print here, you don't have to do this, just an example. This would never be called, because we print out myfunc called and then we return from the function, so that printf test never gets called. And there are reasons for when you would use this, such as returning from a function early based on a condition of some kind. Okay, if we now go back to command prompt, and once again you need to go to the Hello World app directory, and we open up cmd for command prompt, we type cd, right click to paste, press enter, and now we can compile our program again. So just do gcc main.c -o main, press enter. Our program's now compiled, and now if you type main and press enter, you can see myfunc called hello world, and you'll notice that they're all on the same line. What if you wanted a separate line? Well, there's a special way to do that in C. You just do this. So this character here means that you're going to use some sort of special character code of some kind. So by doing this and N, that means new line. Whereas if you did R instead of N, that is a carriage return. So quite commonly you'll see RN. So carriage return and then a new line. But N would just be fine for now. It's fine in most cases. So if you do the same here, and we go back up, press the up arrow twice to come back to your compile command, press enter, gcc compiler now run, and then do main, and we can see they're now on separate lines. So that's how you create new lines in C. You use this. So let me explain another thing that we can do. Let's make a new function. It's going to return an integer, which is a number, by the way. Integer is a number, and we are going to call it mySum, and we're going to have an argument here, integer a, and then another argument, integer b. So what this will do, these will add them both together and return the result. So how do we do that? Well, you do return A plus B. So just like mathematics on a calculator where you might do 20 plus 30, here we do A plus B. So what will happen is when someone calls my sum, they pass in a value here and a value here, and then it gets added together and it returns the result. So let's now get rid of this line here, my func, and we're going to go my sum 5 and 5. So what this does, 5 goes into A as we did here, and then this 5 goes into B. And just to simplify this, I'm going to change this to a 10 to explain this a little better. So 10 goes into A, 5 goes into B. And how that works is, it is in line with these arguments. That's how it works. So we can see my sum takes an integer, so we pass in 10, and it also takes another integer, so we pass in 5. Now we can see we're not storing this result anywhere, so let's now store that result. So if we go integer result equals my sum 10, 5. Now what have we done? We have created a variable. Now variables in C allow you to store information. So in our case, we've created a variable called result, and result will store a number. Now decimal points cannot be in integers. You use doubles for that, or floats, but that'll be explained more later. Now, if we now run that program, nothing would happen because it would sum them together, but we don't output the result. So how do we do that? Well, let me show you. Let's get rid of this. We're going to go printf result equals, no, result is, I'm going to do result is so you don't get confused thinking that the equals is required. Result is, and you do I, %i, and then you do the new line. So what happens here then? Well, currently undefined behavior because we haven't defined the result, we haven't supplied the result. But what will happen is it'll say the result is, and then %i takes from an argument that we provide here. So if we do result and we press Control S to save, so it says result equals my sum 10, 5, which calls this function. We add A and B together, which is in our case is 10 and 5. The result is returned and stored in the result variable, which is an integer, a number. And then we output the result by saying result is %i. Now when the program sees %i, it looks for these arguments passed to us here. And they have to be provided in line with the arguments provided. So for example, if we just change this a little bit more, I want you to do, instead of result is, we're going to get rid of this now because I just need to explain that to you. So we're going to say I plus I equals I. Now here we provide 10 and here we provide 5. And what this will do is the operating system comes in, it runs our program, it sees %i, so then we pull from the first argument here, which is 10. And then we output a plus symbol. Literally, this could even be plus, just to show that they're unrelated. And then it finds another %i, and it puts 5 in there. And then finally, it outputs an equal sign. And then it has a %i again, and it outputs the result. So if we compile that now, go back to the program, up it twice, enter, up it once or twice, main. 10 plus 5 equals 15. So that's how the functions work. So essentially you define a return type, which is this, you define a function name, which is that, and you define arguments in between these brackets. Everything between these curly braces is the code that's run when this function is called. So you can think of functions as ways of splitting up our program into different pieces. They're an essential part of C and they're very important, and they allow you to prevent repeating yourself in code, which is a very important thing for a clean code base. So that is how you define functions. But let's explain a little more now. What happens if main is at the top? Well, there'll be a compile error. If you go back here, run that again. Implicit declaration of function mySum. Okay, why is that then? Well, because these are defined below. So when the compiler comes in and it goes to call mySum doesn't exist yet because the compiler hasn't seen it yet because it's below it. So how do you get around that problem? Well, you define what's known as a prototype. If you copy this line here, paste it here, and just put a semicolon at the end. So what this now says is it says to the compiler, this is a prototype for mySum, this is what it will look like, I will define it later. I don't really care about it right now, but you need to be aware of it for later. That's what this says. And now if we go up to compile it now, you can see it compiles fine, because we've let the compiler know that we will be declaring this later on. Now, this is how the header files work. So these function prototypes exist in the header files. So the one you include this, it'll have a bunch of these for printf. It'll be like that, for example. And when we call printf, it's not defined like this with curlies and everything. It's just a prototype like this, which basically means this exists somewhere. We don't know where it exists yet, but just make a note of it because we're going to be using it. That's all the prototypes do. And again, a very important part of C. So that is function prototypes.